law that brings together the three laws that we've already talked about: Charles, Boyle, and Gay-Lussac. Alright, so this one's called the combined gas law, and it describes the relationship among the pressure, temperature, and volume of an enclosed gas. So the only thing that's going to be staying the same here is the actual amount of gas, so the amount in moles of the gas that we have. So the equation we're going to use here is P1 times V1 over T1 is equal to P2 times V2 over T2. And you can write this all on the top right flap. Alright, so let's see how we would do this. The volume of a gas-filled balloon is 30 liters at 313 Kelvin and 153 kilopascals pressure. What will the volume be at STP? Alright, so now we need to go back and remember what standard temperature and pressure was. So let's make up our chart. So we always write PVT 1, 2. So the volume of the gas-filled balloon is 30 liters. So we know V1 is 30 liters. And that's at 313 Kelvin. And the pressure is 153 kilopascals. So we have all of our ones filled up. Now, what would the volume be at STP? So we're looking for volume. Our pressure at standard temperature and pressure is 101.3 kilopascals. And our temperature, just wanted to double make sure on that. So our temperature at standard temperature and pressure is 273 Kelvin. So what are we looking for here? We're looking for V2. So let's set up our problem. So we have P1 times V1 over T1 is equal to P2 times V2 over T2. We're looking for V2, so we're going to have to multiply by T2 and then divide by P2. So if we're multiplying, it's going to come out here. And then we're going to divide the whole thing by P2. So that's going to look like this. So as you can probably see, this is pretty busy. There's a lot going on here. This is why I always suggest you always write out the equation solving for what you're trying to solve for and then plug your numbers in. Alright, so for my numbers, I have T2 being 273 Kelvin, and that's multiplied by P1 times V1 over T1. So my original pressure was 153 kilopascals. And that's multiplied by my V1, which was 30 liters, over T1, which was 313 Kelvin. And that is all divided by P2, which is 101.3 kilopascals. Make sure when you're plugging this into the calculator, you use parentheses where you need parentheses so you don't make a math error. So the answer I got here was 39.5 liters. Make sure you get that same answer when you plug it into your calculator. Please turn to page 10 in your packet and complete number 1 on worksheet number 4. We can go over that in class tomorrow.